Hello students, welcome back. I am Nigesar, a mathematics teacher at Lux School of Science. Today we'll continue with new types of sums in this chapter. Right? Till now we had seen the sum in which how many three-digit numbers can be formed, four-digit number, even number, divisible by two, numbers divisible by four, arrangement, and so on. Right? Now today we'll study one more type of sum in which any word can be given and the question can be asked that how many words you can form in which these two particular alphabets must be together, they must not be together, and so on. So let's see, I'm giving you an example. In last video, I have given you one example of tree, T-R-E-E, right? How many words we can form? If we see 4, 1, 2, 3, 4, 4 factorial, then 24. But when we tried to form it, there were only 12 words. So see, whenever there is repetition, here, wherever there is repetition, then how many total? 1, 2, 3, 4, 4 factorial upon. How many times key is repeating? 2 times. 2 factorial. Clear? So in this way you have done. So 4 factorial, 24 by 2, that is equal to 12. Clear? So now let me give you one more sum. Let's take independence. Now, if the question is asked, how many letters, how many words you can form using all the alphabets of independence at once. So now just calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12. Clear? Now how many times I is there? One time, so no need to write N. 1, 2, 3. D 1, 2. E 1, 2, 3, 4. Okay, P only once, so no need to write down. C only once. Okay, so now see 3N, 2D, and 4E. 4, 5, 6, 7, 8, 9. Clear? Now three remaining words are P, C, I. Okay, so now the question is first, how many total words can be formed using each letter once? Clear? Now, how can you solve this? Total 12, so 12 factorial. Upon how many times n is repeated? 3 times. 3 factorial. How many times d is repeated? 2 times. How many times e is repeated? 4 factorial. Clear? Now solve it, get your answer. Clear? So whenever there is repetition of the alphabets, you have to use this way. Clear? Now second, if the question is asked that we want I and P together, right? Like B. How many? Let's name this as, okay, here we are already given A. Now second, how many total words can be formed in which I and P are always together? Clear? So see what we have to do. How many total? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are total 12 places. Clear? But now I want I and P together. So let's select out I and P. Remove I and P. So now how many? I removed two places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 places. Now I am placing one more place in which I will put both I and P. Means what I have done, I want I and P together. So I have selected only single place for I and P. So at whatever place I will place I will just place P next to it. So now how many factor? How many ways? Total now 11 upon. How many times N is repeated? 3 times. How many times D is repeated? 2 times. And how many times E is repeated? 4 times. Clear? So now I and P both are at the same place, but they can be arranged in two ways, right? When I take two places for IP, right? Like this way. See, first it will be I, then it will be P, and remaining all the same. First it will be P, then it will be I, then all the same. Now, see, this is a single place. So I can place I and P at one place in two ways, right? IP or PI. So this is the arrangement of all the 11, in which one place consists of two alphabet I and P. Now in how many ways I and P can be arranged? I and B 2, 1. So 2 factorial. So the final answer will be 11 factorial upon 3 factorial, 2 factorial, 4 factorial into 2 factorial. Clear? So now again I am repeating. See, if it is as two alphabets must be adjacent, okay, means together, then subtract two places, count down all the places and add one place for that. That many factorials upon this. Now for that too, how many ways? Two factorial. Just for example, if it is asked that I, P and C, all these three must be together, then what I will do? 12 minus 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? And for one place for all the three, I, P and C. So total 10, 10 factorial upon n, 3 factorial, d, 2 factorial, e, 4 factorial. Clear? Now, how many? I, p, and c. So three places for that. How these three? See, actually, these are not three separate places. These three are from any one place in this. So how many ways these three can arrange? 3 factorial. Clear? Okay? So into 3 factorial. Now, one more right. How many words of how many total words can be formed in which I and P are not together? Okay, if I name this answer as B, clear. Now see, what is C? How many total words can be formed in which I and B are not together? What was this? Total number of words, A. Now from that, what was this? I and P are always together, B. When I will subtract it, what I will get from the total numbers, I have subtracted those words in which I and P are together. So the remaining are the words in which I and P are not together. So this will be your answer. Or else I can write down 12 factorial upon 3 factorial, 2 factorial, 4 factorial minus 11 factorial into 2 factorial upon 3 factorial, 2 factorial, 4 factorial. So first calculate this with calculator, this, and then subtract it. By this way you will get the answer. So remember, two types of question, one in which these two are always together, and second in which these two are never together. Clear? So first note down these three types. Okay, now let's move to some other types. See, here I am only teaching you the method. Okay, we are not dealing with the answers. We're only dealing with the method, with the technique. Now, second, more type D. How many total words can be formed in which all the vowels are together? How many total words can be formed in which all the vowels are together? Now see, just see how many vowels are there here. I, E, okay, two vowels are there. I and E. There are two vowels given here. Clear? So now, what will you do? I only one, E one, two, three, four, four. So total five. Okay, total I am having five. So now what we should do? Total it was 12. 12 minus 5, 7. 1, 2, 3, 4, 5, 6, 7. Clear? Now from these 7, one place we also have to put that flute one more place. And what is this one more place? For all these five means I, E, E, E. All these five I will put in one place. Clear? So seven places for all other and one place is for vowel. So total eight. 8 factorial. Okay. Now eliminate E from here because all the E we have taken in one place. So now how many times N is repeating? 3 factorial. How many times D? 2 factorial. Clear? Now, one place which I have selected for vowels. How many vowels? 5. 1, 2, 3, 4, 5. Here there are 5 vowels. Now, how these 5 vowels will arrange at that one place? So, 5 factorial upon. Now in that 5, how many I? 1. So 1 factorial. How many E? 4. So 4 factorial. So what will be your answer? 8 factorial upon 3 factorial, 2 factorial into 5 factorial upon 4 factorial. Clear? Okay, so this is the way in which you have to answer the questions are like this. The number of alphabets that you want to gather, just take it separately. And for all that, only one place, and for all remaining one place. So that benefactor on the numerator, clear? And the denominator, the number of repetition. But don't take the alphabet which is we are taking here. And then for that 5, how many ways of arrangement? And multiply it. Clear? So just note down this way. Now, the next type is the questions are such like how many words can be formed in which there are 4 alphabets between I and P. Okay. Now see, the question is such that how many words can be formed in which there are 4 alphabets between I and P. Clear? So again, now see 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 10, 11, 12. Okay. So if I put I, position of I and position of P. Clear? At what if I put I at first position, then 1, 2, 3, 4. If I'm putting I, then P must be here. So 1, 2, 3, 4, 5, 6. Right? P must be at sixth position. If I put I at second, P must be at 7. I at third, P must be at 8. I at fourth, P must be at 9. Fifth, 10. Sixth, 11. 7, 12. 8, but 13 we are not having, we are only having 12 places. So these are the different positions of I and P. But can't it be the reverse? Like P at first and I at 6? In question, it is not asked that first must be I and then after 4 alphabets it must be P. The question says only that there must be 4 alphabets between I and P. So also the reverse. So first, how many this? 1, 2, 3, 4, 5, 6, 7. 7 positions. Okay, where first there will be I, after that 4 alphabets and P, right? So 7. Multiply by 2. Why this 2? Reverse P at first, I at 6, P at second, I at 7, so on. So 7 into 2 ways we can arrange I and P. Clear? Now remaining out of 12, I had taken the position of 2. So how many are remaining? 12 minus 2, 10 factorial. So that 10 can be arranged in 10 factorial ways divided by how many n? 3 factorials. How many d? 2 factorials. And how many e? 4 factorial. Okay, got it? What I did, first I calculated the number of places in which I and P can be placed. Number of ways, sorry. Number of ways in which I and P can be placed such that there are 4 alphabets between them. So it was 7 and exchange it. So 7 into 2. Now for remaining 10, 10 factorial by 3 factorial by 2 factorial by 4 factorial. So you can calculate this using your calculator. But this type of sum we will do by this method. Clear? So just note down this way or this type of sum. Okay, students, so that's it for today. Now, this type of sums that are given in exercise 7.3 that will solve in the next video. Thank you.